All right, so we draw these complex molecules as Lewis structures, right? So you probably spent a lot of time in Gen Chem learning about Lewis structures and learning how to draw them. So here we're just going to be basically focusing on Lewis structures of organic compounds. And these are actually often easier than the Lewis structures you drew in Gen Chem. And that's because we're going to basically follow a set of rules. And since we're only dealing with kind of carbon, hydrogen, oxygen, nitrogen, and some halogens, there isn't as much complication. And they basically follow some very simple rules. So most often we'll see them in their ideal bonding forms. And what I mean by that is that there's no formal charge. So we'll check out formal charge later, but for now, we're not going to worry about it. And so this is going to be really important. And so you're going to want to memorize this through practice. So this isn't going to be something that you kind of want to use note cards on to memorize, but you actually want to just memorize it through doing enough problems that you kind of just get it stuck in your head. And so first off, we'll start off with the star of our show, carbon. In this ideal kind of bonding form, carbon is always going to have 4 bonds. And it's going to have no lone pairs. And so there's carbon. I'm just going to draw 4 bonds. At the end of these bonds, there could be all kinds of different things. Next up is nitrogen. Nitrogen will have 3 bonds and 1 lone pair. So it will look something like this. After that is oxygen. Oxygen will have 2 bonds and 2 lone pairs. After that, we have hydrogen. Hydrogen will have 1 bond and no lone pairs. And since it only has 1 bond, the hydrogen will always be terminal, or at the end of a molecule, right? It can only bond once, so you can't continue on that molecule once you add that hydrogen at that spot. And then after that, we have our halogens, which are generally denoted as X. So halogens could be anything from chlorine, fluorine, chlorine, bromine, or iodine. And they'll have 1 bond and 3 lone pairs. So these will also be terminal because they can only form 1 bond, similar to hydrogen. And so while you learned a whole lot of complex rules for Lewis structures in general chemistry, when we go to organic chemistry, they follow relatively simple rules, and it's these bonding structures, right? Carbon's going to have 4 bonds, nitrogen 3, oxygen 2, hydrogen and halogens 1. And so if you're given what's known as the condensed structure, it's really easy to draw the Lewis structure. So for example, if we're given the condensed structure of ethanol, that would be CH3, CH2, OH. And so you can see how it kind of gives you the answer, right? Don't focus on the hydrogens because they're terminal. And so you just draw out the other elements and then add in the hydrogens at the end, right? And so we can see we kind of have this carbon that we start off with. And this carbon is, of course, going to have 4 bonds. And then next to this carbon, it's got another carbon. So we'll add that there. That will also have 4 bonds. And then after that is the oxygen. This oxygen will only have 2 bonds and 2 lone pairs. And then we just add all the hydrogens, right? We can see that the first carbon has 3 hydrogens, which works out perfectly from the way we had it. The second carbon has 2 hydrogens, which also works out perfectly. And then finally, the oxygen has 1 hydrogen, which also works out perfectly. So you can see when you're given the condensed formula, drawing the Lewis structure is relatively easy, but it does take some practice. So for example, if we had CH3, CH3, right? These two compounds are very similar. If you think about the actual molecular formula, they're the same, but the condensed formula is actually different, right? And so let's start off here. So we'll start off with carbon. With its 4 bonds, that carbon is then attached to an oxygen, which has 2 bonds and 2 lone pairs, which is attached to another carbon that has 4 bonds. And then simply, we can take a look at our condensed formula and see how many hydrogens we should have, and it should work out perfectly, and here it does, right? This first carbon has 3 hydrogens, the oxygen has no hydrogens, and then the final carbon also has 3 hydrogens. Of course, it's not just carbon, oxygen, and hydrogen. Another popular element is going to be nitrogen. So let's just give an example of that. CH3, NH2. This is methylamine. And so again, we have carbon with its 4 bonds. We have nitrogen that has 3 bonds and 1 lone pair. And then we add in the hydrogens and make sure that it corresponds correctly to our formula. And there we go. We have the Lewis structure of nitrogen. So if you can just follow these simple motifs, it's not too bad. It does get a little bit more complex in that double and triple bonds can be involved and often are. And so let's go back up here where we said carbon has 4 bonds and we drew it with 4 single bonds. And that can certainly be the case, but it doesn't have to be, right? It could be that carbon has 4 single bonds, or carbon could have 1 double bond and 2 single bonds. Or maybe carbon has 2 double bonds. Or maybe carbon has a triple bond and a single bond, right? All of those are 4 bonds. Same with nitrogen here. Maybe nitrogen has 3 single bonds and a lone pair, or maybe nitrogen has 1 double bond, 1 single bond, and a lone pair, or maybe nitrogen has 1 triple bond and a lone pair. Same with oxygen. Maybe it has 2 bonds and 2 lone pairs, or maybe it has 1 double bond and 2 lone pairs. Either way, you can see that we have 4 bonds or 8 valence electrons. Hydrogen and the halogens always have a single bond. Can't really make that a double or a triple bond for obvious reasons. And so let's see an example of that. So we have HCCH, right? We're given the condensed formula there. Let's try to draw the Lewis structure. And so we start off with this C, right? We have 4 bonds that's connected to another C that has 4 bonds. And then if we take a look at our condensed formula, we only have 1 H over here. And then the other C also only has 1 H. And so you can see that these carbons need 4 bonds each. And so instead of having 4 single bonds, each one of these carbons has 1 triple bond and 1 single bond. So there's that structure right there. That's acetylene with each carbon having a single and a triple bond. You'll see other motifs as well. So for example, CH3COOH. So we start off with a carbon, right? It tells us that it has 3 H's. It's going to have another bond to a carbon, which can have up to 4 bonds. And so if you look at this formula, you might think that it goes oxygen, oxygen, hydrogen, but then you're going to have problems with these single bonds. And so this does take a little bit of practice and just kind of knowing what you're doing. In this case, the COOH represents a carboxylic acid, in which case this carbon actually has a double bond oxygen and then a singly bound oxygen. If you try to draw any other way, it's not going to work out. Things aren't going to have 4 bonds. And so there's that CH3 right there. And then the COOH is represented right over here. Same over here, CH3, CO, CH3. So we have our carbon with 4 bonds connected to another carbon. And so then there's this component right here with our 3 H's. And then we have this carbon right over here connected to an oxygen, which can have up to 2 bonds. This carbon is going to have 4 bonds. And so then it might look like this CH3 is then attached to the oxygen. But if you try to put this CH3 here, you're not going to have anything to do with these bonds over here. And so we can't actually do that. The CH3 goes over here. And then we see we have this dangling bond over here, no hydrogens. And so we fuse those together to make a double bond. And then, of course, add in the lone pairs for the oxygen, right? So this does take some practice, but you want to do a couple practice ones, and then you'll see a lot of common motifs, and it shouldn't be too bad. Another thing that you'll commonly see is things in brackets or parentheses. So, for example, the CH32, CHOH. And so here, if we start off with this carbon right here, right, we can tell it has one hydrogen on it, and then after that, there's an OH. And then here we can see that we have two CH3s, right? So this carbon is going to be connected to two other carbons that each have 3 hydrogens on them. And that's how you go from condensed formulas to these Lewis structures. These still follow the guidelines for your Lewis structures from general chemistry. It's just that the rules are a bit simplified because we're dealing with basically carbon, oxygen, hydrogen, nitrogen, and none of them can ever have more than 8 valence electrons. These elements can never have more than 8 valence electrons, which makes their rules much simpler than the other ones. Of course, there are some difficulties and some practice that you need to be careful of, especially when it comes to these oxygens and how you place these oxygens. You'll see common groups with these oxygens either being singly or doubly bound. And so that's where the practice comes in.